So now we move on to the discussion on logistic regression. Logistic, it is based on the logistical curve, and that is that same as type of cumulative probability distribution. And for all the values of the regressor, the value of the dependent variable, that is the probability of a positive or a response, bracket close, it falls between 0 and 1. So this is what you discuss, this is what is the case of a logistic regression. The values, it will fall between 0 and 1. And it is having that S shape, we will see that. So this probability function is now the second thing, it falls between 0 and 1. We have seen that for all values of the regressor, the value of the dependent variable, that is the probability of a positive response, falls between 0 and 1. And the second important thing over here is that the probability function is a non-linear function following a logistical curve. Non-linear function, we will show it, we represent now the probability of a positive response. Pi is equal to Pi when y is equal to 1, it's a positive response, and if y is equal to 0, then if we have a negative response, is equal to 1 divided by 1 plus e raised to the power minus beta 1 plus beta 2 xi. So with this model formulation, we are taking a non-linear function into consideration. Now, no longer this means the slope of the entire function is the same as we have assumed over there in the linear probability model. Now, it varies, the slope varies. So, similarly, the probability of a negative response is equal to 1 minus Pi is equal to e raised to the power minus beta 1 plus beta 2 xi divided by 1 minus e raised to the power minus beta 1 plus beta 2 xi. So when we are taking a term like this gives a non-linear relationship. Our term over here, it shows a non-linear relationship. So, upon dividing the probability, now here a new another thing which need to be introduced is odds ratio. This example we have over here, and we represent this as a case with an odds ratio. Odds ratio. What is odds ratio? The probability of success divided by the probability of failure. So this is what is basically the odds ratio. Whenever you see refer to any research paper or any discussion on probability model, there means the emphasis is more on odds ratio. You will not consider the values of what is the value of beta 1, what is the value of beta 2, but we will look at the results will be interpreted based on the column of odds ratio. So upon dividing the probability of a positive response with the probability of a negative response, we get the odds ratio of an individual in the favor of the individual possessing this is we have taken a different case, but we will take the same case of possessing and what you call it with the example which we are discussing of possessing a car, his personal car. So odds ratio is equal to Pi divided by 1 minus Pi, which is equal to e raised to the power Bi plus B1 plus B2 xi. Now, in order to solve this type of problem, this type of relationship where we have exponential raised to the power something, we take the most simple way is we take the log on both sides and then we will derive the logit function. So when we take the log on both sides, so Li stands for logistic regression, is equal to log Pi divided by 1 minus Pi. And since we have applied log to the left hand side, we also apply log to the right hand side. So it becomes log e raised to the power beta 1 plus beta 2 xi. Now, when we take the log, that is this log e raised to the power beta 1 plus beta 2 xi, this we can write it as simply beta 1 plus beta 2 xi. So, Li is equal to log P divided by 1 minus Pi is equal to beta 1 plus beta 2 xi, and this is what you refer to as the logit function. Now, we have derived this logit function, that is log Pi divided by 1 upon Pi is equal to beta 1 plus beta 2 xi, and we assume beta 2 plus beta 1 plus beta 2 xi as Zi. Simply we assume it by a term Z. So we can say that 1 upon 1 plus e raised to the power minus beta 1 plus beta 2 xi is equal to, since we have assumed Z is equal to beta 1 plus beta 2 xi, is equal to 1 divided by 1 plus e raised to the power Zi, that is equal to 1 divided by 1 plus, we can write it as 1 plus 1 divided by 1 plus 1 divided by e raised to the power Zi. Now we take the Ezi from the denominator to the numerator. So finally we can write Ezi divided by 1 plus e raised to the power Zi. So this is our Pi. Pi is finally equal to e raised to the power Zi divided by 1 plus e raised to the power Zi. Your Pi is the cumulative logistic distribution, and Pi is the probability of having a car, and 1 minus Pi in our example is the probability of not having a car. So Pi is the probability, and Pi is what is? It is the cumulative logistic distribution. Now we see the things. So Zi ranges from minus infinity to plus infinity. Our Zi, it ranges from minus infinity to plus infinity, and so in that case my Pi ranges from 0 to 1. Our Zi ranges from minus infinity to plus infinity. It can assume any of the values, but a Pi, it ranges from 0 and 1. That is, we have that condition in our mind. Probability, it can never be more than 1, and probability can never be less than 0. So Li is equal to log P upon 1 upon Pi is equal to Zi is equal to beta 1 plus beta xi. Now your Z can extend from minus infinity to plus infinity. But in this structure of things, your x will restrict themselves from 0 to 1. So let's take a case when xi is plus infinity. When the value of xi is plus infinity, z is also equal to positive infinity. E raised to the power minus z, which is a function of which is there in our logit function, tends to 0, so Pi is equal to 1. And the opposite of it, when xi is tends to minus infinity, z also tends to minus infinity. E raised to the power minus z, it tends to plus 1, and Pi is equal to 0. So as Pi is non-linear not only in xi but also in beta, hence we cannot do OLS as the model is non-linear in parameter. OLS, we consider only the case where the model is, where the variable where either the relationship is linear or The variable is non-linear, which can be converted into linear. We can take x square. We can do in OLS, if you remember our discussions, we can do y is equal to alpha plus beta x square plus u. You can estimate that. But y is equal to alpha plus beta square x, we cannot estimate. This we cannot estimate. This we can estimate. So we cannot use this OLS. So what we use, we normally use your maximum likelihood method, ML method. So now, as Pi ranges from 0 to 1, Zi ranges from minus infinity to plus infinity, and your Li also ranges from minus infinity to plus infinity. Similarly, as Pi lies between 0 and 1, your Li is not bounded by 0 and 1. Li is linear in xi, but the probabilities are not. That means delta p upon delta xi is equal to, you can write delta p upon delta xi is equal to, you can write it as b2p 1 minus p. So this delta 2 upon delta xi is not constant. It varies from point to point depending upon what is your p. So your means, the thing is, your Li is linear in xi, but the probabilities, they are not. So we can say that Pi and xi are non-linearly related. Pi is not linear not only in xi but also in b. We cannot do ALS as the model is not linear in parameter. Now, if the coefficient beta 1 is positive, as x increases, the probability that y is equal to 1 will increase. If the coefficient beta 2 is negative, as x increases, the probability that y is equal to 1 decreases. That is the same logic we have. But the thing is, Pi and xi, they are not linearly related. So those two issues of the linear probability model, that is, your value may extend beyond 0 and 1. Here we are saying, okay, let it extend beyond 0 and 1. But the probability will not extend beyond 0 and 1. First thing. Second thing, there is no linear relationship. It's not that it is constant. Your value of beta 2 is constant throughout. Here the value of beta 2 depends upon p1 minus p. So as the probability changes, your value of beta will change. Now we do some small proofs. One is that Pi plus 1 minus Pi, that is the probability of success and probability of probability of failure, of not having, probability of having a car and not having the probability of car is equal to 1. So we can say Pi is, we have seen, is equal to 1 divided by 1 minus e raised to the power minus zi, where zi is equal to beta 1 plus beta 2 xi. And the 1 minus Pi probability, or the same thing is there, but it's e raised to the power, it's not minus zi, but rather it is 1 upon 1 plus e raised to the power zi. So what we can do, we can when we take try to rearrange the things, and we can write it as 1 plus e raised to the power minus z plus 1 plus ez divided by, with bracket open, 1 plus e raised to the power minus z multiplied by 1 plus e raised to the power z, only z. So this we can write it as, we can, when we are taking the terms, this 1 and 1, it becomes 2, and then we are left with plus e raised to the power minus z and simple e raised to the power z, and beneath we open the brackets, and we can we can simply write it as 1 plus e raised to the power minus z plus ez plus e raised to the power minus z ez. So now e raised to the power minus z and e raised to the power z. So with what we can write it as, e raised to the power z minus z is equal to 0. So this term, it becomes 0. So in the numerator we are left with only 2, and in the denominator we have 1 plus e raised to the power minus z multiplied by e raised to the power z. So again, this also, this also becomes 1. So this is equal to 2 divided by 2, that is equal to 1. So now, what is the probability? The probability that that is pi plus 1 minus pi, it is equal to 1. Now this odds ratio, that is what is commonly reported in any studies which are using this logistic regression. This odds ratio, we have seen it is p divided by 1 minus pi, and this has the very important implication. Say pi is equal to 0.8. Then odds ratio will be 0.8 divided by 1 minus 0.8. So that is equal to 0.8 divided by 0.2, that is equal to 0.4. That is equal to 4. This means the odd ratio is 4. What does this mean? This implies that the pi, the probability that the event will happen, and the odds are 4:1 in favor of the event happening. Odds ratio of 4 means that the probability that the person will have a car is 4:1 in favor of the person having a car. So if we just expand these terms, pi, if you remember, is equal to 1 upon 1 plus e raised to the power minus z. And what is 1 upon 1 minus pi? It is just 1 divided by 1 plus e raised to the power z. So when we are writing pi divided by 1 minus pi, we can say it is equal to 1 upon 1 plus e raised to the power z. And for this term, because it is in the here there is a division sign, we flip it. The denominator becomes the numerator and the numerator becomes the denominator likewise, and we change with the sign changes to multiplication. So the final terms become 1 upon 1 plus e raised to the power minus z multiplied by 1 plus e raised to the power z divided by 1. This we can rearrange as 1 plus e raised to the power z divided by 1 plus 1 divided by ez. Means we are just, if we don't want to write in terms of minus, so e raised to the power minus z, if we can write it as 1 upon e raised to the power z. So this we can further write it as 1 plus e raised to the power z divided by ez plus 1 upon ez. We write as 1 plus, we can again write it as 1 plus ez divided by ez plus 1 upon simplifying the denominator multiplied by ez. So finally what is left is ez cancelled, 1 cancelled, we are left with ez only. So what is the odds ratio? Odds ratio pi divided by 1 minus pi is equal to e raised to the power zi, and zi is equal to beta 1 plus beta 2x. So what we can say is the odds ratio is equal to e raised to the power beta 1 plus beta 2xi. This is my odds ratio, and odds ratio give how much in favor, means what is the odds that this thing will happen. So we get a ratio that is 4:1, as anything like that. Whatever you find, when we divide your pi divided by 1 minus pi, if its number is 4, it means there is 4:1 is the probability that that person will have a car. We quickly take a recap at the features. P tends to 0 to 1, Z tends to minus infinity to plus infinity, L tends to minus infinity to plus infinity. Even if the probability lies between 0 and 1, the Li, that is the logit is not bound by the values of 0 and 1. They can go beyond 0 and 1, but my probability is still between 0 and 1. Next, Li is linear in X, agreed, but the probabilities, they are not linear. Probabilities are rather non-linear, because your delta p upon delta x is equal to beta 2 multiplied by p1 minus p. So your delta p upon delta x is not constant. It varies from point to point depending upon what is the p. Depending upon p means you have what is its beta 2 p 1 minus p. So this can vary. Your beta 2 varies from one point to another. We cannot estimate by OLS. We use maximum likelihood method. So ln p divided by 1 minus pi is equal to beta 1 plus beta 2 xi. If the happening of an event is success, if we define having a car is a success, pi is equal to 1, then 1 upon 1 minus 1 is equal to 1 upon 0 is equal to 0. We cannot do OLS, we do ML, maximum likelihood model. So, although we are not going into the details of maximum likelihood model, nowadays we have many softwares. The most commonly used in in primary data cases is the SPSS. If you don't go to for the cases of R and Python, we can do it by SPSS, and then we therein you can simply estimate it. Now, what is the case over here, that we do not use R square. We use things like pseudo R square. They are not exactly R square, but they are called as pseudo R square. We will see to it. And again, we do not use that F test for testing the analysis of variance likely. Rather, means whether the model is fit or not, for estimating that whether your R square is significant or not, whether your model fit is significant or whether your model is fit or not, we do this F test. Now, herein to check the case whether your model is fit or not, we do not use your old traditional F test which we used in OLS. Rather, we use things like likelihood ratio. So here the things are a bit different. That is your model estimation. In order to check for the validity and fit of the model, you have to look at the pseudo R square, you have to look at the likelihood ratios and things like that. So, again a recap, when L is positive, it means the value of x increases. The odds of the dependent variable to become 1 increases. Means if your L is positive, it means when the value of x increases, when income increases, the odds of having a car increases. When L is negative, when x increases, when income increases, the odds that the person will have a car decreases. Your beta 2, it is basically beta 2, it measures change in L for a unit change in x. That is, it tells us how the log of odds ratio, it tells us how the log of the odds ratio changes as income increases. So if your odds ratio is greater than 1, it increases the chance that y is equal to 1. So if odds ratio is more than 1, then we can say that there is a higher chance that this person will have a car, and if your odds ratio is less than 1, it decreases the chance that this person will have a car, or it decreases the chance that y is equal to 1. So this is your significance. The main thing is the odds ratio in this logit model. Through odds ratio is greater than 1, it increases the chance that y is equal to 1. If odds ratio is less than 1, it decreases the chance that y is equal to 1. Now, apart from this logit model, there is another model which also has that same S type of curve which is required, and this is referred to as the probit model. So the function of probit model is written as probability y is equal to 1 is equal to 1 divided by under root 2 pi where with the differential it ranges from beta 1 plus beta 2 xi from minus infinity e raised to the power t minus t square divided by t divided by 2 multiplied by dt. So basically this function, it shows that the t is it is based on a normal cumulative density function, and your t is your standardized normal variable. Uh, we will restrict our discussions on probit, because the logic is the same which we have used in logit regression. But as you can see in the figure, a logit model is flatter at the tails relative to the probit model. Or we can say that in probit models, the conditional probability pi goes to 0 or goes to 1 faster than in the logit model. So this means it is, as you see, this is not logic, this is logistic. So this dotted curve, the small with the curve, is your logit curve, and your the darkened line of S is your probit curve. It is much closer to 1 and it is much closer to 0 as compared to the logit. So you can say that this logit model is relatively flatter at the tails than the probit model. Again, the estimation of this you can do through softwares. There are plenty of softwares available. You simply have to give the command over there. Now a question arises, that is when to use this logit and when to use this probit. What is the difference between these two? So we can see the difference in terms of, say, interpretability of coefficient. These logit models provide coefficients that are interpreted in terms of odd ratios. If interpreting results in terms of odd ratios is preferred or makes more sense, more theoretically sense, then logit model might be appropriate. Next is this computational efficiency. Logit models are computationally more efficient. It's said that as compared to probit models, especially if you are dealing with large data sets. Now, this problem of heteroscedasticity, which was there as a problem in linear probability model. So, this logit models are less sensitive to heteroscedasticity as compared to probit models. Then for goodness of it, in some cases, logit models may exhibit better goodness of fit compared to probit models. Although, see, this will depend on a specific data set and what is the specific context your study is on. As far as the probit analysis is concerned, our first case is the probability models are based on the assumptions of normal distribution. So if this assumption is more appropriate for your data, or if you have theoretical reasons to assume that, assume normality, then probit model is more suitable. If you think that your data is normal and if maybe you check it also, then you can go for probit. Probit is a better, it will give better model fit. Then see, the next thing is the probit models have a more straightforward Bayesian interpretation, as they are based on cumulative distribution function of the standard normal distribution. We use our standard normal distribution and t in this case. And another important thing is, normally if we don't have a very large sample size, that probit models can be more robust in small sample sizes compared to your logit models. Also, one last point could be that the probit models have a symmetrical distribution, a symmetrical distributional assumption, which might be desirable in certain cases where symmetry is assumed or preferred. So, we will be stopping our discussion on probit model. In today's lecture, what we had basically done is, we had just concentrated on why we need a certain type of different models wherein the dependent variable is dichotomous in nature. To treat these models, we cannot use our normal OLS, because apart from the problems of heteroscedasticity and normality, the two major issues is the probability the resultant what you get calculating the probability, it should not go more than 1 and less than 0. And also assuming a linear relationship in many cases like this is nonsensical. So what we do, we go for other models. We have discussed a logit model in detail. We have discussed basically the concepts. We did not go for the estimation of it, because that is done by maximum likelihood method, and that is beyond the scope of this lecture. So means we are assuming that these models will be estimated through any of the softwares like SPSS or R. It is also available in Stata and all these things. So now what the thing is, what are how to enter. We have learned basically how to interpret the models. That you can get the results from the software, but how to interpret the models of a logistic regression we have seen. And then we did had a small discussion on the probit model. Probit model is just similar to logit model, only here we are using a standard normal distribution, as and there we are using a logistic distribution. Both of them are S-shaped, fine, but this is probit. It is more helpful. It is used when you are sure that the data is having a normal distribution, and it is also better. It is better than logit if your sample size is small, and there are a few other characteristics also. So our purpose of today's lecture was to give you a theoretical foundation of or how the things happen in basically in logistic regression, and how you can interpret the results which you can be getting from any of the commonly used softwares like SPSS or R or Stata. With this, I end today's lecture. Hope that the lecture was clear to you. Thank you. Goodbye.